Okay, college algebra, let's talk 1.7. The front page in the notes is just a reminder on how inequalities look generally. There are some important things that we need to go over, though, that I just want to talk about. When you have an equal to sign for an end, you use a bracket instead of parentheses. When you have just a regular less than or greater than, you use a parentheses. Now, for infinity and negative infinity, remember these are concepts and not actual numbers. So those will always get parentheses because you're never going to actually get to negative infinity or positive infinity. So it's important you understand that those will always have parentheses regardless of what happens. Now a reminder for solving inequality equations, it doesn't matter if you add or subtract by any kind of number, it does not change the direction of an inequality. The only time the inequality changes directions is if you multiply or divide by a negative number, and that's when the inequality changes directions. So let's get started on what these look like. We'll warm up a little bit with some linears, and then we will get to inequalities that represent the quadratics and the rationals. So some of the last few sections that we've worked with. So linear inequalities, 4 minus 3x is less than or equal to 7 plus 2x. So we solve them exactly like linear equations. So we move our x's to one side. So 4 minus 5x is less than or equal to 7. Subtraction doesn't do anything. Again, subtract 4. Negative 5x is less than or equal to 3. Then we divide by negative 5. Now we're dividing or multiplying by a negative number. That means x is greater than or equal to negative 3/5. That means any value that's negative 3/5 or bigger is a solution. So because of the equal sign, we start at negative 3/5, and we keep going forever to numbers that are larger than 3/5, all the way up to infinity. Now, even though there's an equal sign, again, this is going to have a parentheses because infinity is a concept. It just represents the fact that we get to go on forever. So that's the solution set. So this would be inequality notation. This is interval notation. Almost all of your homework requires interval notation, so you should get used to that. Now, number 2. This is a 3-part equation. All that really means is anything you do to one part, you do to all 3 parts. So let's start by multiplying everything by 5 to clear the fraction. So that goes to all 3 parts. 5 times negative 2 is negative 10. The 5's cancel in the middle. They divide to 1, and 5 times 4 is 20. Now we're solving for x, so we subtract 3 on all 3 sides. So negative 13 is less than or equal to 2x. It's less than or equal to 17. And then divide by 2. Negative 13 halves is less than or equal to x is less than or equal to 17 halves. And so this represents starting at a value, but we have a cap this time. So we start at negative 13 halves. It's included because of the equal sign, and we go all the way to 17 halves. So how does this work with quadratics? Well, for quadratics, it's important to note the idea of a quadratic. If we're talking about, we always set quadratics equal to 0. Now if we look at a quadratic, it looks something like that. The point is, though, that it crosses from positive to negative only at the roots. And the roots are what we get when we actually set it equal to 0. But then we're going to have to test areas to see if they're positive or negative, depending on what we're looking for. So what we do here is x squared minus x minus 12 will set it equal to 0. And we'll factor potentially x minus 4 times x plus 3 equals 0. So those points, those roots, are x equals 4 and x equals negative 3 in that case. So what we'll do in this class is we'll make a test chart, negative 3 and 4. And we just need to test one point in any of the areas between those, because that one point will represent everything. Because again, the only place you can cross 0 is at the roots. So if something in the middle of here is positive, then the rest of them are positive. Something's negative, the rest of them are negative. So we pick easy numbers to test. In the middle, 0 is probably the easiest. Number bigger than 4 is 5. Number less than -3 is -4, but you can pick anything. You can either plug it into the factored form, or you can plug it into the original. Either one is fine. So let's plug in -4. I'm going to do it into the factored form. We have -4 minus 4 times -4 plus 3. That's negative. Since we're only caring about the sign, that's negative times negative. Negative times negative is positive. Well, let's plug in 0. We've got 0 minus 4 times 0 plus 3. That's negative times positive, which is negative. Plug in 5. 5 minus 4 times 5 plus 3. That's positive times positive, which is positive. Now, which one are we looking for? We're looking for numbers that are less than 0. So that means this is a solution, but these two are not. So that means all the numbers from -3 to 4 are solutions. Now, it's a less than sign and not a less than or equal to sign, so we use parentheses. So everything from -3 to 4 is my solution set. So it's important that we're able to do this properly. So let's do another problem. (2x² plus 5x minus 12 is greater than or equal to 0. Again, factor. I'm going to remind you how to factor when a is greater than 1. That means there's a 2 in front. Multiply the 2 times -12 is -24. And then we're looking for factors of -24 that add to 5. Be 8 and -3. So now we're going to split the middle term in 2. This is like, you know, when you distribute, you have those two middle terms that you combine. We're undoing that. So this is 2x² plus 8x. It doesn't matter the order either. Minus 3x minus 12 equals 0. Now we group them to factor. What do 2x² and 8x share? A 2x, leaving an x plus 4. What do -3 and -12 share? They share a -3. If the first term is negative, you always take the negative with it, leaving an x plus 4. So now that these are common, the outsides are one of our factor, that 2x and -3. The x plus 4 is the other factor. So that means when I set these equal to 0, either x is 3/2 here, or x is -4. So again, I have to do the chess chart. We have -4, 3/2. Easy number in the middle, 0. Easy number bigger than 3/2, 2. Easy number smaller than -4, again, -5. So I'm not going to draw out what we're doing. I'm just going to plug them in. 2 times -5 is -10. So this is negative. Negative times negative, because -5 plus 4 is also negative. So that gives me a positive. Plugging in 0, I get a negative times a positive, which is a negative. Plugging in 2, I get 4 minus 3, which is 1, so it's positive. And 2 plus 4 is 6, which is positive. So positive times positive is positive. Now, what kind of numbers am I looking for in this problem? I'm looking for positive numbers because I have greater than or equal to 0 in my problem. Okay, so if it's greater than or equal to 0, that means these two outside ones are solutions and the middle is not. So this is the numbers from -4 all the way down. So that would be -infinity to -4, and since there's an equal sign, we use the brackets. Here, this is the numbers from 3/2 all the way to positive infinity. So 3/2 to infinity. But to make my solution set, I need to combine those because they're both solutions. So the way we do that, so we go -infinity to -4. This union represents I'm bringing two groups together, and 3/2 to infinity. And we will continue in the next video.